at 1C.4, our master learning objective is I can identify an expression as rational or irrational by multiplying and dividing radical numbers to simplify the expression. Okay? So we did adding and subtracting, and now we're doing multiplying and dividing. So, a rational number times a rational number, if I multiply two rationals, it's always going to be rational. A rational times an irrational is always going to be irrational. Where we get into the tricky part is irrational times irrational could be either. Okay. So this is the part we're really going to be looking at. If I'm multiplying two irrational numbers, and again, those irrational numbers have square roots, is my answer rational or irrational in the end? Okay. So, multiply the radical expression, then determine whether your answer is rational or irrational. How we multiply here is we multiply the outside and then multiply the inside. So, here, our outside technically is 1, but we don't have to really worry about it if there's no outside. So I'm just going to multiply the inside. And inside I have 10 and 10. And the square root of 10 is 100. And then I always want to check if I can actually simplify that square root. There we go. I can. I did the operation. I typed this whole thing in the calculator, right? So then my answer is just 10. Okay. The biggest mistake I see is students putting square root of 10. Okay. I already did that square root operation. If I wrote 5 plus 3, I wouldn't put 8 and then still have a plus sign. Okay? I no longer have a square root. I did the operation. Looking at number 2, or example 2, right? Again, multiply the outside. My numbers on the outside are 3 and 4. My numbers on the inside are 2 and 5. Three times 4 is 12, and 2 times 5 is 10. I want to check if I can simplify the square root of 10. I get a horrible decimal. It cannot be simplified into an integer, so I'm going to leave this as my answer. Okay. For both of these, I want to decide if they're rational or irrational. So here, when I multiplied two irrational numbers, I got just the number 10. And the number 10 is rational because it's just an integer, right? 12 square root of 10 is irrational, right? Because it still has that square root that did not simplify. Let's look at example 3. Square root of 7 times the square root of 28. No outside, just the inside. So it's the square root of 7 times 28. Is 196. The other way you can think about this is the same way we did our other problems, where this is also the square root of 14 squared, right? If you go back to that C1, C2 activity. Okay. And our square roots cancel, so I'm left with 14. Okay. 14 is a rational number, it's just an integer. So this way or this way is a 2. I could also easily type this in my calculator. Right, and I get 14. So 2 ways of thinking about it. Inside is, or outside is 2 and 5. Inside is 3 and 10. 2 times 5 is 10. 3 times 10 is 30. I cannot take the square root of 30. Right? And if I try dividing 30 by like 25, nope, get a fraction, by 16. Right? If I try all those different things, nothing works. Okay, so square root of 30 does not simplify in any way. It's irrational, right? So again, I was just dividing to check if there's any perfect squares in it, just like we did in C2. All right, square root 6 times square root 15. All right. We'll multiply the inside. Then 6 times 15 is 90. Now again, can I take the square root of 90? I can always check that first. No, but I probably can simplify it. Maybe. So I'll start 90 divided by 81. Nope. 90 divided by 64. Nope. 90 divided by, our next perfect square is 49. Nope. I'm going to go through all of them. 36, 25, 16. Ooh, 9 works, okay? I quickly scrolled through all my perfect squares by memory. If I'm assuming that as of now you don't have all of your perfect squares memorized, and that is fine. Look back at your chart, right, from C2, and on the test you'll have most of those squares there. Okay. So 90 is really the same as 9 times 10. Which is the square root of 9 times the square root of 10. If you look at that chart, 9 is 3 squared. Those cancel. 3 square root 10. Okay. So now, while we were able to simplify it slightly, it still has a square root. It's irrational. Next one, same type of thing. Multiplying the outside, we have 5 times 2. Multiplying the inside, we have 2 times 10. 5 times 2 is 10. 2 times 10 is 20. I'm just going to break down the 10, but I want to see if I can break down that 20. The first square root after 20 is 16. Nope. 9. Nope. After 9 is 4. Yep. So 4, and we got 5 from it. So that's 10 times square root 4 times square root 5. The square root of 4 is 2 squared. Yay, those cancel. I now have 10 times 2 square root 5, and then 10 times 2 is 20. Again, while it's simplified, there's still a square root, so it is irrational. All right, this one's getting long, but go ahead and turn the page. We're going to do our division problems really quick. Now we're going to divide. Same type of steps, right? Divide the outside, divide the inside. So 27, square root 27 divided by square root 3 is the square root of 27 divided by 3. You can do 27 divided by 3 in your calculator, but you get 9. And I can easily simplify 9, square root of 9 with my calculator, and it's 3. Okay, and that's... Okay. And that's 3 because 3 squared, right? And the squareds cancel out. Figured I'd fit that in there. Again, I feel like this method is nice to remember that that square or root goes away, because that is one of the biggest mistakes that I see. Square root of 85 divided by square root of 5. So we just write it as 1 square root. 85 over 5 is 17. And I'm going to save us time. That has no way of simplifying. 17 is prime. So this is irrational. All right, now looking at example 9, this is really what we're doing in our multiplication too. Right, we divide the outside and divide the inside. $18 divided by 3 is 6. 90 divided by 6 is 15. Again, for the sake of time, I'm going to let you know this does not simplify. Okay, it is irrational. Still has that square root. Same thing with this last one, right? We have 14 divided by 7. And then we have 48 divided by 3. 14 divided by 7 is 2. 48 divided by 3 is 16. Now I want to check. This one does simplify. 16 is in my list of perfect squares. 16 is 4 squared. My square and my square root cancel out. I'm left with just 4, and 2 times 4 is 8. So that one is rational. All right, that is it. Go ahead and work on your activity.